So in this video, I'm gonna talk about static frictional force versus kinetic friction. Yeah, I'm gonna talk about the two. And I just want to point out some of the common mistakes and just to get the idea. Okay, so we say if an object is stationary, right? If it's not moving, then we say that the magnitude of the frictional force, of the kinetic frictional force, yeah, that has to be less than or equal to mu sub s, yeah, times the normal force. Yeah, that's the idea. If an object is stationary, then and this makes sense. The kinetic friction has to be less than or equal to the static frictional force. Okay, and typically, if an object is stationary, yeah, so if it's stationary, then we could rightfully assume that mu sub s, which is a static frictional force, is greater than mu sub k, which is a kinetic frictional force, and intuitively that makes sense. Okay, intuitively that makes sense, but here's why I don't kind of agree with this. Okay, I don't agree with how it's written, and it could be tricky because at one point we're saying the frictional force is less than or equal to the static frictional force, and then another point we're saying that mu sub s is greater than mu sub k. So it doesn't make any sense. Okay, so I'm going to show you the point that I'm trying to bear across here. So maybe if I have say for example, this is a surface, okay? I have a surface and I have some sort of mass. I'm pulling with some sort of tension, so maybe this is the force of tension, okay? I'm pulling with some sort of tension and I have, static frictional force between the block and the ground, okay? So the object is stationary, okay? Now, maybe maybe I'm gonna put down some choice here. So I want you to tell me which one do you think is correct. Okay, if the object is indeed stationary, okay, is it one? Is it two? Is it one? Is it two? Is it three? Where the magnitude of frictional force is actually less than the magnitude of tension force. Okay, so which one of these options would it be? If the object is stationary, in fact, this is stationary, what can we assume? Can we assume that the static frictional force is greater than the tension force? Could we assume number three? Could we say the static frictional force is less than the tension force? Well, that number three would not make any sense because again, if our tension force is actually greater than the static frictional force, then the object will be moving. Okay, so we know that cannot be true. Okay, now which one is it? Which one of these two will be the answer? Okay, and this is a multiple choice, so you can't choose which one. Now it comes back to this idea, which is really the reason why I say this kind of notation that they give you is kind of weird because they're saying that the frictional force is less than or equal to the static frictional force. Okay, and in this case, the object is stationary. So which one would it be? Would it be that a frictional force is greater than tension force? Obviously, that is absolutely true. One could make sense of that. That okay, well, if the static frictional force is greater than the tension force, then the object doesn't move. But in fact, the answer is two. The static frictional force is equal to the tension force. Okay, and that's why this equal sign here kind of slips a lot of people. Okay, this is very important. And the idea I'm trying to bring across is this. The take home is this. Static frictional force will only do enough of the opposing force to stop the block from moving. Okay, so what do I mean? Okay, well, let's bring across the question. A large crate has a mass of 130 kilograms, sits on a horizontal floor, okay? You push on the crate with a horizontal force of 580 newtons, but the crate does not move. The coefficient of static friction between the crate and the floor is 0.5, okay? What is the magnitude of static frictional force acting on the crate? Okay, so let's talk about the scenario here. We have some sort of, crate, and let's represent it as a block, and it has some sort of mass, and you apply a force, okay? So I don't know, let's say it's a tension force. So you apply a force in this direction. So, okay, the block doesn't move. We have some sort of static friction here. The block doesn't move. You apply the force and the block doesn't move. Okay. Well, one could assume that if the block doesn't move, the static frictional force has to be greater than the tension force, which logically that seems to make sense. And so here's what a lot of students will do. Okay, we know in order for us to find the magnitude of the static frictional force, we know the static frictional force of F sub k is equal to mu sub F sub s is equal to mu sub s times the normal force, which is just mg. Okay, so here's what a lot of people do. I'll say 0.5 times mg, so we know the block is 130. So that's the mass times the gravitational force, 9.8 meters per second squared. Okay, and if we take those numbers and plug it in 0.5 times 130 times 9.8, I get 637 newtons. Now that's one of my answer choices, but in fact this is wrong. Okay, the actual answer is D, 580. And here's the idea. Again, this is the idea I was trying to bring across. The static frictional force will only do equal and opposite, only just enough to oppose the block from moving. So if you're applying a force of 500 newtons, static friction will do only enough to equal that force, which will be 500, which will be also 580 newtons. Okay, and that's my point I was trying to bring across. So that's why, to me, this kind of, if you don't see this equal sign here, then it becomes it becomes really difficult, and you don't see what I'm saying. So the major point that I'm trying to bring across here is that static friction will only do just enough to oppose the force that you're applying. So, you know, if the tension force is 580, the static friction force is going to be the opposite. It's going to be exactly 580. It's not going to be just like what I did here, which is what a lot of people are tempted to do.